video is for the Blended Algebra 2 class, Unit 5, Lesson 1, Practice number 2. So we'll do a couple questions from the practice. We're going to start with the multiple choice question on number 4. Now it says the turning point of the parabola. We want to find the turning point for the parabola, x squared plus 5x minus 2. There's two ways to do this. You can either, I would actually, honestly, if it's multiple choice and you're allowed to use your calculator, I would just use Desmos. I would type x squared plus 5x minus 2. Into Desmos, click on the turning point and see that it's at negative 2.5, negative 8.25, which is C. Now, if you didn't have Desmos, which I would let you use Desmos, this unit will have some non-calculator part, but this would be on the calculator part. You could use the formula opposite of B over 2A to find the x value of the vertex. So here you would have to know that A is 1, B is 5, C is negative 2. You would take the opposite of 5, which is B, over 2 times 1, and you would get x is negative 2.5. That would at least allow you to eliminate B and A, and you'd be between C and D. To find the y value, you would have to put this x of negative 2.5 in for both of the x's. So you'd have negative 2.5 squared plus 5 times negative 2.5 minus 2. You would type that into Desmos to get the y value of negative 8.25. So two ways. The faster way is just to use your tools and your resources of Desmos. Now number 7 says write the equation of a parabola in vertex form that has a vertex at 5, 4. You need to know that the 5 is an x, the y is a 4. Here's vertex form. Now what we learned today about vertex form is that in our parentheses goes the opposite of the x value of our vertex. So I'm going to put an x, but if I have a positive 5, in the parentheses goes a minus 5. We have to have a squared outside the parentheses for vertex form. And then the number on the end is the same as the y value. So that would be your vertex form equation. All right, number 8 here. It says use the formula opposite of b over 2a to find the turning point of the quadratic, then state the axis of symmetry and the y-intercept. All right, so the axis of symmetry, remember to find that, we use this formula that I gave you, opposite of b over 2a. We need to know what a and b are. A is the first number you see, b is the next number. So for this formula, for the x equals, for the axis of symmetry, I take the opposite of negative 24, which is positive 24, divided by 2 times a. A is negative 2. Well, that gives me 24 over negative 4, which is negative 6. That's the equation of our axis of symmetry. X equals negative 6. That's the invisible line that goes through the middle of your parabola. Now the turning point, the vertex of the parabola, has the same x value. We need to find the y. And we did this back in number 4. To find the y value of the vertex, we're going to take this x value and put it into the equation for x. Negative 2 times negative 6 squared minus 24 times negative 6 minus 67. And we can go ahead and type that right into Desmos. So I'll take negative 2, close your parentheses, one in the negative to square it, and then minus 67, lots of negatives here. But you end up getting 5. Now one thing you could also do, if you were unsure of how to use the formula, even though it said to use the formula, is to graph the equation in Desmos. You can see here, the vertex is what we found, negative 6, 5. All right, so we got equals 5 here, so my vertex is at negative 6, 5. Now, maximum or minimum, we can see from the picture that the vertex here is a maximum because it's the highest point. The other way you can figure that out is by looking at the first number, the a here. A is negative 2. And if that first number is negative, it means my parabola is going to open down. When I open down, the vertex is a maximum. finally, what's the y-intercept? Well, we're on the equation, so let's look here. The y-intercept when you're in standard form only is the number on the end, negative 67. Two other ways you can do this. You can either look at Desmos, look at the graph here. Now I'm going to have to scroll down a little bit to see the y-intercept. So I cross, but as I get closer, it looks like I cross down here at 0, negative 67. Now, if you didn't want to do all that scrolling, or you didn't think to do all the scrolling, the third way you could find the x-intercept would be to make a table of the function. The x-intercept always happens where x equals 0. So I can see here that the y value that goes with 0 is negative 67. All right, last problem we're going to do. Number 10. You have to graph the parabola and identify the information. So we're going to start with x plus 4, the quantity squared, minus 4. Now the turning point, we just talked about this back in number 7. The turning point is the same as the vertex. It's an ordered pair. The x value is the opposite of what's in the parentheses, so here that would be negative 4. And then the same as what's outside the parentheses. We can look at the picture in a minute, but to find if it's a max or min, we look out in front of the parentheses. It's positive. There is no negative sign, which means your parabola is going to open up, and that turning point is going to be a minimum. And the axis of symmetry is always x equals the x value from the vertex. Those are always the same. Now the rest of this we can do by looking at the picture, and we can double check our work from the picture as well. So let's go to Desmos, and we'll type in x plus 4, the quantity squared, minus 4. So here's our picture. We know it's a minimum. We found the right minimum, negative 4, negative 4. And we said our axis of symmetry was that x equals negative 4, which when I graph it, does go through the center of that parabola. So it is the axis of symmetry. Now let's take a second here and let's make a table and plot our points. We need to find the right points. It doesn't look like 1 and 2 are going to help us here. Those numbers are too big. So is 0. But let's see. If I look at my graph, looks like I have a point, negative 7, 5 here. That might be the last point that fits on my graph. So I'm going to start my table at negative 7. Then we'll do negative 6. Oops, negative 5. There we go. These look like they're going to fit all of my points. Okay, so take a minute here. You can pause the video if you need to. Make your own table on Desmos. And then you should see we should plot from negative 7 to negative 1 in order to make our picture. Right. So let's go back here. So negative 7 plus 5. All right, here's your picture. The y-intercept we can't get from the picture because we don't cross the axis, but when I look at Desmos, I already put in 0 for my x value. That means the y value here is at 12. So the y-intercept is at 0, 12. The domain for every parabola is all real numbers. Remember we said our domain is always all real numbers because I have an arrow going to the left forever and an arrow going to the right forever. My range, I have a lowest y value here, which happens at negative 4, included, so we use a square bracket, and my arrows go up towards infinity. The roots, the zeros, or the x-intercepts, look like they are at negative 6 and negative 2. If you have questions on the other problems on your packet, check the answers that are on the packet, check the key on Canvas, or ask your teacher for some help.